Okay, so in this next example, we have a river with a current of 4 miles per hour and a motorboat traveling perpendicular to the current at 12 miles per hour. What's the resultant speed of the boat, and at what angle do you hit the opposite riverbank? So we need to find this as our resultant vector. So we know that they're perpendicular. So to find the speed, we can call it S. We've got the square root of 4 squared plus 12 squared. Oops. So that equals about 12.649 miles per hour. And then to find the angle you hit the riverbank, that's going to be this angle here. And if it helps to think of this other side as the riverbank, you're hitting it at this angle here, which is the same as the angle over here because we have parallel. We're assuming the river as the banks are parallel. So we've got the tangent of theta equals 12 over 4, which implies that the angle is 71.565 degrees. So the resultant speed is 12.649 miles per hour, and we're going to hit the riverbank at 71.565 degrees. Now, example 12, the last one we're going to do, a plane traveling 500 miles per hour called the airspeed in the direction of 120 degrees encounters a wind of 80 miles per hour in the direction of 45 degrees. What's the resultant speed, called the ground speed, and the direction of the plane? If it helps to draw a picture, you can, or we got the plane here at 120 degree angle. So the plane's vector would be 500 times the cosine of 120 degrees is its I component, and the j component would be 500 times the sine of 120 degrees. Now the wind has a direction of 45 degrees and a resultant speed of 80 miles an hour. So for the wind, we have 80 times the cosine of 45 degrees for the horizontal component, and the vertical component is 80 times the sine of 45 degrees. So to find the resultant speed, we add these together, and when we do that, we get negative 193.431 for the horizontal component and 489.581 for the vertical component. Now again, that's the vector. We need to find its magnitude and its direction. So we think about that in terms of a triangle, with the horizontal piece being negative 193, the vertical piece being 489. We can find the speed as the hypotenuse of the triangle. So the speed of the plane is 526.408 miles per hour. And the angle, when you use tangent, you find this theta over here, you get 68.44 degrees. But remember, we want to measure it. In this case, we should probably measure it off the positive x-axis. So that would be 180 minus 68. So our angle would be 111.559 degrees. Make sure you're using your calculator's store feature when you go through all of the adding and subtracting of the components.